Hey there, deep divers. Buckle up because today we're going to the final frontier. Well, sort of. We're diving headfirst into satellite networks,
Oh, wow.
exploring how to build custom-tailored virtual networks right up in orbit.
Okay.
Imagine seamless global internet, swarms of drones controlled from space and connecting even the most remote corners of the planet.
Yeah.
That's the power of satellite network slicing, and we're breaking it all down today.
Ugh.
Ready to blast off.
I am. Picture this. You're trying to build a network not on solid ground, but on a network of satellites constantly zipping around Earth.
Okay, that sounds like a pretty wild puzzle to solve.
It is.
So we're talking about creating virtual networks like separate lanes on a data superhighway, but in space.
Exactly. It's called satellite network slicing,
Okay.
and it's poised to be a game changer for 6G and beyond.
Wow.
By dividing a single physical satellite network into multiple virtual ones, we can create dedicated resources for different applications,
It makes sense.
whether it's lightning-fast speeds for streaming or ultra-low latency latency for drones.
So why is this so much trickier with satellites than with networks here on Earth?
Well, satellite networks are a whole different beast. They rely entirely on wireless links, which are much more vulnerable to interference.
Okay.
And the nodes themselves, the satellites, are constantly moving,
Right.
making it incredibly difficult to maintain stable connections.
So it's like trying to build a network on a foundation that's constantly shifting.
Yes,
No wonder they call this satellite network slice planning.
or SNSP for short.
A real challenge.
It is. SNSP involves figuring out how to efficiently embed virtual network requests onto this dynamic satellite network.
So how do you actually fit these virtual networks onto a network of moving satellites?
It's a two-step process. First, you have to figure out where to place the virtual nodes on the physical satellites.
So like which satellite will be responsible for connecting a specific user?
Precisely. The research dives into two main approaches to node embedding.
Okay.
The closest node method, you pick the satellite closest to the user to minimize delay.
Makes sense. But I imagine those satellites move pretty quickly.
They do. Wouldn't you need to constantly switch connections as they go out of range?
That's the trade-off. That's where the second approach, longest service available node, comes in.
Okay.
This method prioritizes choosing the satellite that will stay within range the longest.
Ah, so it's like taking the highway instead of the back roads.
Exactly.
It might be a slightly longer route, but you'll cruise at a consistent speed without constant interruptions.
Exactly. Now, once you've placed your virtual nodes, you need to connect them using the satellite network's links.
Right, because what good is a network if the nodes can't talk to each other? What are some of the strategies?
Before we get into that, the researchers actually highlighted a clever preliminary step called pre-link embedding.
Interesting. So tell me more about this pre-link embedding step.
It identifies the bottleneck in the relevant part of the satellite network.
Okay.
If the requested network slice needs more capacity than that bottleneck allows, the request is rejected right away.
Makes sense. Saves a lot of wasted effort.
Mm-hmm.
So once you've cleared that hurdle, there are two primary link embedding methods: shortest path and maximum flow path.
Got it.
Shortest path focuses on finding the most direct route between the nodes to minimize the time it takes data to travel.
Okay, so straight to the point, minimizing those delays.
Yes,
And what about the maximum flow path method?
this one prioritizes maximizing the available data capacity on the path, ensuring a stable and robust connection.
So shortest path is all about speed, while maximum flow path prioritizes stability and bandwidth.
Interesting. So we've got our nodes placed and our links established. Are we done?
Not quite. Remember those pesky moving satellites we talked about? That's where the challenge of handovers comes in.
Ah, right. Even with the best laid plans, those satellites are going to keep zipping around,
Right.
and eventually they'll move out of range.
They will?
So how do you ensure a seamless connection when that happens?
That's the million-dollar question. The research delves into two main strategies: adding new links and re-embedding.
The first approach, adding new links, is like putting a Band-Aid on the problem.
Okay.
As the satellite moves, you simply add new links to the slice to maintain connectivity.
It sounds straightforward enough.
Well, it can lead to a more complex and potentially less efficient routing path.
I see.
So it works in a pinch, but it's not ideal in the long run.
What about the second approach, re-embedding?
This one is more like performing surgery.
Oh,
When a handover is necessary, you essentially rerun the entire process to find a brand new path that meets the slice's requirements.
so you're essentially hitting the reset button and finding the absolute best path.
Precisely. It's all about ensuring consistent performance even in the face of constant change.
This raises an interesting question. how do you even decide when the best time to execute a handover is?
That's a good question.
And how do you weigh the computational costs of these different strategies against the potential performance benefits?
Those are some of the key questions researchers are still grappling with.
And to get a better sense of how these strategies actually play out in the real world, the researchers didn't just theorize, they ran simulations.
Yes, they did.
Fascinating! So they built a virtual space playground to test out these ideas. Tell me more about those simulations.
Well, they discovered that node selection and handover strategies have the biggest impact on overall performance.
So it's not just about the technical nuts and bolts of embedding, but also about making smart decisions about how to manage those connections over time.
Exactly. And they uncovered another crucial insight. The capacity of the inter-satellite links, those connections between satellites, is a major bottleneck.
Okay, so it's like having a multi-lane highway, but with single-lane on-ramps and off-ramps.
Exactly.
It doesn't matter how much capacity you have on the main highway if you can't get the data on and off efficiently.
A perfect analogy.
Mm-hmm.
And there was one finding that even surprised the researchers a bit. Splitting data across multiple paths instead of sending it all along a single route didn't actually provide much benefit in most scenarios.
Really? I would have thought spreading the data out would improve performance.
It seems intuitive.
Kind of like diversifying your investments.
But in their simulations, the overhead of managing those multiple paths outweighed the potential gains. It's something to keep an eye on, though, as demands for data continue to skyrocket.
Right. The rules of the game might change as technology evolves. Well, I don't know about you, but my head is already spinning with all this information. We've just scratched the surface of satellite network slicing, but it's clear that there's a lot to unpack here.
There is.
Ready to take a quick breather before we launch into part 2? We'll explore the mind-blowing potential applications of this technology and how it could transform the way we live, work, and connect with the world.
Sounds good.
Stay tuned. Welcome back, deep divers. I don't know about you, but I'm still processing all those technical details from the first part.
Yeah, me too.
It's amazing how much ingenuity goes into building these networks in space.
It's a fascinating field.
Yeah.
And the challenges are definitely complex. But I think it's important to step back and consider why this is all so important.
Okay.
What are the real-world applications driving this research?
Right.
What kind of future are we talking about?
Okay, let's shift gears from the technical nuts and bolts and zoom out to the big picture.
Okay.
Paint us a picture of the possibilities. What are some of the most exciting potential applications of satellite network slicing?
Well, one of the most transformative applications is the potential to bridge the digital divide
Oh, wow.
and bring reliable internet connectivity to even the most remote and underserved areas of the globe.
So we're talking about connecting those communities that have been left behind by traditional terrestrial networks.
Exactly.
Places where laying fiber optic cables just isn't feasible.
Exactly. Imagine rural communities, disaster relief efforts, scientific expeditions in extreme environments,
Wow.
all with seamless access to the information and opportunities that come with high-speed internet.
That's incredible. It could truly level the playing field
You could?
and empower people regardless of their location. What other applications are on the horizon?
Another area that's ripe for disruption is transportation.
Oh.
Think about urban air mobility,
Hmm.
where swarms of autonomous flying taxis could whisk you across a city in minutes,
Wow.
all coordinated by dedicated network slices.
Rush hour would become a thing of the past. And wouldn't that have massive impact on reducing traffic congestion and emissions in our cities?
Absolutely. And it's not just about moving people.
Okay.
Imagine drone delivery networks, powered by satellite network, slicing, bringing packages right to your doorstep,
Okay.
or transporting medical supplies to remote areas with incredible speed and efficiency.
Okay, now I'm really starting to see the transformative potential here.
Yeah.
We're not just talking about incremental improvements,
Right.
but a whole new way of living and interacting with the world.
Exactly. And this technology could also revolutionize the way we monitor and understand our planet.
How so?
With dedicated network slices, satellites could collect and transmit vast amounts of data about our environment in real time.
So we're talking about a significant leap forward in Earth observation and remote sensing.
Precisely. Imagine a world where we can track the health of our forests, oceans, and glaciers with unprecedented detail.
Okay.
A world where we can predict and respond to natural disasters with greater accuracy.
This is starting to sound less like science fiction and more like a glimpse into a future
It is.
where we have the tools to tackle some of the most pressing challenges facing humanity. It's incredibly exciting.
It is.
But let's be realistic. Every rose has its thorns, right? What are some of the potential downsides or risks we need to be aware of?
That's an important point.
Yeah.
With any powerful technology, there are always potential downsides to consider.
Right.
One major concern is the growing problem of space debris.
Right. We don't want to create a scenario where satellites are constantly dodging debris like a cosmic game of dodgeball.
Exactly. As we launch more and more satellites to support these networks, we need to prioritize responsible and sustainable approaches to satellite deployment.
So responsible space traffic management is absolutely crucial.
It is.
What other concerns are there?
Another critical consideration is data security and privacy.
Right.
With these vast networks transmitting sensitive information,
Yeah.
we need to ensure that the data is protected from cyber attacks and unauthorized access.
So it's not just about building these networks, it's about building them with security and privacy baked in from the ground up.
Absolutely.
Yeah.
We also need to be mindful of the potential for exacerbating the digital divide.
Right.
It's crucial to ensure equitable access to this technology.
Yeah.
So the benefits are shared by everyone, not just those in developed countries or with the resources to afford it.
Right. We don't want to create a world where only a select few can enjoy the benefits of this space age connectivity.
Right.
Bridging that gap will require collaboration between governments, industry, and nonprofit organizations. What about the regulatory landscape? Are there concerns about how these networks will be governed?
That's another key consideration.
Yeah.
As these networks become increasingly complex and interconnected, we need clear guidelines and international agreements to ensure responsible and sustainable development.
So it's a bit like the Wild West of space right now.
It is.
We need to establish some rules of the road before things get too chaotic up there.
That's a good analogy. It's a rapidly evolving landscape, and it's crucial to create a framework that fosters innovation while protecting the interests of all stakeholders.
Okay.
But before we wrap up this part, I want to highlight one concept that's particularly relevant to our listeners' interest in optimization.
Ooh, I'm all ears.
It's the idea of dynamic network slicing.
Okay.
Remember how we discussed those constantly moving satellites and the challenge of handovers?
Yeah.
Well, imagine a network that could adapt to those changes in real time, automatically reconfiguring the slices to optimize performance based on changing demands and conditions.
So it's like a self-driving network, constantly adjusting its own settings to handle traffic jams and detours without any human intervention.
That's a great way to think about it. Dynamic network slicing relies on sophisticated algorithms and machine learning to monitor network conditions, predict future demands, and adjust the slices accordingly.
So it's like having a team of expert air traffic controllers in space, making sure the data flows smoothly no matter what's happening down here on Earth.
Exactly.
That's incredible.
It is. Dynamic network slicing has the potential to unlock a new level of efficiency and responsiveness, allowing these networks to adapt to the ever-changing needs of our increasingly connected world.
Okay, depth divers. I think we've officially reached information overload. We've covered a lot of ground in this part, from the mind-blowing potential of satellite network slicing to the ethical and practical considerations we need to address.
It's a lot to take in.
But hold on tight, because in part 3, we're going to bring it all home and explore what these advancements could mean for you and how they might impact your life in the coming years. Welcome back, deep divers. We've journeyed through the technical intricacies of satellite network slicing, explored its potential to reshape industries, and even grappled with the ethical considerations it raises. But now let's bring it all down to earth.
Okay.
How could these advancements actually touch your life?
Well, the most immediate impact for many will likely be a noticeable improvement in internet connectivity.
Okay.
As these sophisticated satellite networks come online, they'll play a bigger role in delivering high-speed internet, even to those frustrating dead zones we all encounter.
So even if you're miles from civilization, you could still be streaming your favorite shows or finally conquering that online game without lag. Sign me up.
Exactly. And it's not just about speed.
Okay.
It's about reliability. Imagine if a natural disaster strikes and terrestrial networks go down, but thanks to satellite network slicing, you're still able to connect with loved ones or access crucial information.
Okay.
That's a game changer for disaster preparedness and response.
It's like having a backup internet lifeline beamed down from space. Pretty incredible. Now, thinking beyond just internet access, what about those mind-blowing applications we discussed earlier?
Yeah.
How close are we to actually seeing those become a reality?
It's closer than you might think. Remember those flying taxis we talked about?
Uh-huh.
Companies are already testing and developing these urban air mobility solutions,
Wow.
and satellite network slicing will play a crucial role in making them safe and reliable.
I can already picture it. Zipping across the city, high above the traffic, enjoying breathtaking views on my way to work.
Yeah,
It sounds futuristic, but it might be just around the corner.
it really might be.
Yeah.
And think about the impact on package delivery.
Okay.
Imagine ordering something online and having it delivered by a drone within hours, even if you live in a rural area.
No more waiting days or weeks for deliveries. It would be a dream come true for online shoppers.
It would.
And for those in remote areas who rely on timely delivery of essential goods, this could be life-changing.
Absolutely. And the implications go beyond convenience.
Right.
We talked about how satellite network slicing could revolutionize Earth observation.
Yes.
Imagine a future where we can predict natural disasters with far greater accuracy, track deforestation in real time, or monitor the health of our oceans with unprecedented detail.
It's like giving our planet a checkup, constantly monitoring its vital signs
Yeah.
and alerting us to potential problems before they become crises. It's amazing to think about the positive impact this technology could have on environmental protection and sustainability.
It's truly remarkable.
Yeah.
But it's important to remember that these are just a few examples.
Okay.
The potential applications of satellite network slicing are vast and constantly evolving.
Right.
It's like opening a door to a whole new world of possibilities.
It's exciting to think about what innovations might emerge as this technology matures, but let's be real, when are we actually going to see these advancements become mainstream? Are we talking years, decades, or are we getting ahead of ourselves?
It's still early days, and there are certainly hurdles to overcome.
Right.
We still need to address those potential downsides we discussed. Space debris, data security, the digital divide.
Yeah.
But the pace of innovation in this field is remarkable.
Okay.
We're already seeing significant investments, and the first commercial applications are beginning to roll out.
So it's not just a pipe dream. It's something that's actively being developed and could have a tangible impact on our lives within the next few years.
I firmly believe so.
Okay.
It's a field ripe with opportunity, and it's only a matter of time before these advancements start to touch every aspect of our lives.
As we wrap up this deep dive, I think the key takeaway is that satellite network slicing isn't just about bits and bytes and technical jargon.
Right.
It's about pushing the boundaries of what's possible, connecting humanity in new ways, and ultimately creating a future that's more sustainable, more equitable, and more connected than ever before. It's a pretty inspiring thought, isn't it?
What's truly fascinating is that for centuries, space has been this distant, almost mythical realm. Now with satellite networks, slicing space is becoming interwoven with our daily lives, enabling innovations we never thought possible.
Wow.
It's a testament to human ingenuity and a reminder that our capacity for progress is limitless.
So as you go about your day, take a moment to look up at the sky and consider the amazing possibilities unfolding above us.
Yeah.
Who knows what incredible discoveries and breakthroughs await us in this new era of space-based connectivity.
The possibilities are truly endless. And perhaps in a few years, we can revisit this topic on the deep dive and see how far we've come.
I'd love that. Until then, keep looking up deep divers and never stop exploring.